If you want more information, you can click here, but I will explain it. So it's free for a year with limited usage, and you don't have access to a lot of things. But for those things that you need to learn, it's perfect. It's more than enough. Now, you will go to create a free account. And again, I don't think you will need my help for that. What is important here to know? It will ask for your credit card. It will take €1 to verify the account and then give you back that €1. So it will not take anything basically, but it will first charge you for €1, then give you back that €1. Okay? So please do this. Again, this is a couple of minutes, and then we'll continue. Right. That does not mean that you cannot use everything. You can use absolutely everything, but it will cost you. Right? So it is very important, if you don't want to make expenses, it is very important that you stay within those free tier limitations. Right? It normally tells you exactly what is free, what is going to cost you.
Okay.
But sometimes it is not so straightforward. That's why it's a good approach that I saw with students in this past few years now, 6, 7 that we're doing cloud, that you also create some sort of a blocker for this. One of the ways how you can do it is create a budget, right? It's how much you want to spend per month. After that, it can do different things. It can send you a notification, or it can just immediately suspend your services. Depends how you create it. As complex as it is, AWS also has pretty complex accounting settings, right? Because it is normally made for companies that do this on a large scale, right? Those are their main customers. There's even a role just for the budget. You will see that when we do cloud. They even have a role just for the budget. Not one, multiple roles. Multiple roles. What I would like to do now is in this search field, because this is the fastest, they have so many options now. Just type budget, and it will give you this billing and cost management. Here there is budgets, right? I have created one for me. You can do it in different ways, right? If you don't want to spend anything, you will create a zero spend budget, or you can put some amount. I put $1 because I do a lot of things. Sometimes I do things that cost, so I allow it to go over a zero, and I spend some money on it, and I do it with students. It's not that important. I think, again, if I spend €10 per month on AWS, it's not a big deal. Create a budget, and there are customized, there are templates. What is most appropriate, so that you don't have a lot of editing and it's fastest, just use this zero spend budget. It will notify you immediately if you do anything that costs more than 1 cent. which means 0, right? So more than 1 cent, you will immediately get notification. You can suspend the service, put emails that you want to get the alert. So here you can put multiple ones. And as it says, you will be notified via email when any spend above 1 cent is incurred.
But it just alerts you, it doesn't stop the.
This one does not stop it, yes. This does not stop it. This is the easiest way. You can of course edit this. There are, as I said, multiple ways how to do this. But this is, I would say, the most easiest one, right? There's a usage budget, savings plan, reservation. Depends how you deploy things in the cloud. You can play with this if you want, but again, it can get very complicated if you go into this. And then I'm afraid you would risk somebody making an issue. So I think this is the easiest thing, right? So you can immediately see this becomes very complex. And AWS has become a monster. It's impossible to manipulate manually anymore. Impossible. When I started using AWS for the first time in 2016, that's when I first got my AWS account, because that's when I started with Adidas. This list was less than what you just see now on the screen. It was maybe like this part. Those were the services. That's maybe even too much. Now, look at this, right? That's everything. It's absolutely everything. I mean, if you want to launch something into space, it's here. Literally, it is like that. Unbelievable amounts of services. And I will explain some that are more security related than the others, but we will do that tomorrow. So, if you have created this, then you should be pretty okay that even if you make some wrong choices, you will not. It will not go unnoticed, right? So it will immediately alert you that there is a cost associated, and you can stop that. It should be pretty straightforward for the service that we are using, but still, this is an additional safety measure. Let me use this time just to briefly go through this, and then when we come back, we'll do the practical. Just quickly to run through this. So, different folders, you should know the purpose of them. One of the most commonly used folders for attacks, and that's why it's mentioned here and also in some other slides, is the temp folder in Linux. This is where often you will find the attacks originating from, malware being hosted, and so on. Why are they using this folder specifically?
Because you have all the rights.
The sticky byte.
Not that you have all the rights. Yes, that is the reason, but it is the fact that everybody has all the rights of this folder.
Yeah.
That is more relevant, right? It doesn't matter how he went into the machine, right? With privileges. In this folder, he can do whatever he wants.
Yeah.
So this is and this is a security issue, right? Because from this folder, everybody, it doesn't matter in which way it came to this machine, can read, write, and execute.
Yeah.
Read, write, and execute. That's the biggest issue with the temp folder, and that's why normally in a lot of companies, when you are establishing any CM rules, right, you are monitoring for events in the temp folder. So that's That's an important thing, and for the people who are working in SOC teams and so on, or configuring alerts, writing rules, this should be one of the things that they should take care of, as I said. One of the most often used things because of these specific permission things, okay? Any questions? I will, as I said, I will just go through these slides. When there is something important, I will make a note. But if you're interested in something, or just please ask a question. And I will also mention some of the more important topics on these folders when we talk about some specific behavior of the attacks. Naming files, so the nomenclature is pretty clear, right? So it's the path name folder, then the file. What is important here that you don't lose your idea where you are, right? Because it's often the case that I have seen, and not just with students, right? Also with people who are supposed to be professionals, that if they are not very experienced in Linux, they lose the idea where they are, right? So they actually forget where they are working and what is the location. So always, if you're not really sure where you are and what you're doing, just try with pwd, right, to give you the current working directory. And don't forget that Linux is using the Unix-based file name system, right? Which means that the dot actually has a pretty significant meaning, right? We used dot when we are moving to directory like cd dot, right? It starts with a dot and so on, but also dot is a convention used for hiding files and folders, right? So anything in a file name or a folder name starting with a dot is hidden. It is a primitive way of hiding stuff because you can list all hidden files, right? And that's why when you're working in Linux, when you're using ls, my advice, and that's why I advise also my guys in the team when we do this, always list the files with an option to show hidden files, right? That should be your common approach, right? List everything with the option to show hidden files, because although it's primitive, it is still used, right? It is unusual to see that in some attack they didn't use it at some point to hide files, because it's, first of all, because it's easy, right? So always remember that the dot is also for hiding. We have these special files, right? Some of them like user bin or bin, either for root or for the user, right? Bin is for the root, user bin is for you as a user. Contains system commands, right? And it's also part of the attack, because the fact that you can or you cannot access certain command also influences the attack. And they want to be able to execute all system commands. There is also sbin, so command used by system admins. etc, very important for configuration files. Also, it is not uncommon that you will see that they have edited files in etc, so that they can run something, right? Opening shells and so on. var is basically where you will go for all the logs. I will be surprised that in the environment that you should be working, right? So it means companies, right? Corporate environment, you will have local logging. Normally in this kind of environments, the logs are collected centrally. They go to some CM solution, not on the machine. But that is true only for some of the logs. But you should always remember, and that's why this is still very, very, very important. When we create a CM, what is the biggest challenge when you're establishing a CM solution?
Correlation of logs, correlation of different logs types.
Yes,
To be sure you catch all the event.
that's the thing.
Collecting the good logs?
But what are good logs?
Logs that are pertinent.
River.
What? That's exactly the question.
Yeah.
To what? Pertinent to what? When I talked with Microsoft for this minute visit attack, I asked the guy who was really high in that hierarchy, I asked him, this was a very specific attack, right? This Chinese attack. And I asked him, what would be your recommendation? Which types of logs should we now add to our CM collection to be able to detect this attack? You know what he told me? He says, I don't know. He says, I don't know. Because today it was this technique, tomorrow it will be something else. He said, if we had those logs, we would have detected it ourselves. They also didn't have the logs. So the biggest problem with CM is which logs you will collect. So which logs you will collect. And why don't you collect all the logs?
You saturate disk too much amount.
And you get
Money.
costly.
Costs money. Costs money. Every device generates
So
huge amount of logs, collecting them, first of all, and the most important of all, that costs a lot of money, right? It costs a lot of money. Second, it's also, let's look at it realistically, it's also a performance thing, right? Imagine the infrastructure that will have to process every log from a network that has 500,000 devices.
oh my god,
Right? That's impossible,
it's
right?
irrealistic.
I mean, you would need to have a nuclear power plant behind it to facilitate something like this.
Yeah, but you can segment it.
And we do, absolutely, right? So you sit down and you say, okay, you take, for example, my attack framework, and you say, okay, based on the framework, these are the most known attack vectors. In this attack vector, these are the most known, right, steps. And if I do this in this attack, it will create an entry in this type of log, right? So if I'm trying to detect if somebody created a new user account, which log will I look at? Right? Look at it from that perspective. So we collect not just limited logs, but also limited amount of events, right? So you will say, okay, I will log only from this level of event, or I will take only these types of events. So logging successful, logging failed, and so on. Depends what you do. The rest is not lost. The rest is not lost. It is still on that machine. Right? If it's created and not sent centrally, it is still on that machine. That's why, and I've seen that again in a lot of situations, people should take the logs from a local device because they might have something that is not there. Unfortunately, as I said, people are not aware of that. They think that if it's not in the CM, it's not nowhere, which is not true, right? There's a lot of people now relying on technology to solve issues. And technology often does not solve things. It helps but does not solve. So this manual type of work has not gone. It is still not possible to have everything in the central system. That's why we are taking things local. In Windows, this is a safe way of investigating, right? So if I would be now examining an intrusion in Windows, I would have no problem going, for example, and looking at the event logs, right? What is the problem with Linux here?
There are several folders or several files that provide events.
You just see if I have. It's a different. I don't know. Let me get back to it. The problem here, which you will not have in Windows, is the trust. Can you trust Linux logs?
Because we can modify it because it's a file.
Not just it's a file, it's a text file. Right? What are event.txt files? When you go to Windows, right, you take an evtx file, it's a binary file, right? It cannot be edited or modified. If you type history in your hash now, what will it show?
What you type.
Everything you type, right? What is the effort for the attacker to remove any of those command lines? About 2 seconds, right?
There is a special for this.
Yes, there is a command there, yes. You just, and do you have any way of knowing that he did that? Unless you're actually monitoring for it. No.
You can see there is movement on the file, the history of.
What it's not, it doesn't have timestamps.
I don't know.
It doesn't have timestamps,
That's not like you, that's why it's.
right? So there's no timestamp in that specific file. So it's very difficult to trust Linux logs due to the fact that they are easily editable.
So if you have the shell, you can see it.
Yes, but what if you don't collect that log in a scene?
Yeah.
That's the issue, right? So when you're collecting logs locally, and you should also talk with your admin what policies they are applying to make sure that they verify those logs, right? The fact that they're editable doesn't mean that they can be actually editable. Not so easy, right? There's also techniques to prevent manipulation of the logs, which you should also know because we'll talk about it in the cloud. Because that same issue happens in the cloud. If we talk about the cloud logs, they have the same problem you have in Linux because it's what the Linux anyway, right? On the node. So, as I said, I will also mention these techniques, but the fact that they are easily editable, if you're a smart admin, you have prevented that by establishing rules that will either alert you that somebody is trying to make modifications or prevent that modification without additional permissions, authentication, and so on. Right. Again, that depends how good your security is. And you will often go in environments that are not so secure. So, just remember that everything goes into var, all the logs there. Standard type of commands, I know for sure you know how to execute this. Linux is using the standard Unix concept of the standard input and standard output, right? What is a standard input? The default input for your Linux is keyboard. Default output is your monitor, right? You can change that, and you can redirect outputs. That's often done, right? You can read from the file, then from the keyboard, and so on. It is often used. As I said, there are multiple shells. These shells also allow execution of scripts. So you have the entire bash script language. Let's call it a language, right? If you don't know how to do it, please, for those who might not have experience, please remember how to redirect the output, because we often, especially during investigations, redirect our outputs. This same methodology of redirecting the output is used for collecting the data from a Linux device over network. That's why you should remember how to output, right? So one chevron is for output. I would always advise you to use two, not one. This, I don't know how you call it in French, but crater or chevron, how they say it in America, doesn't matter. But my advice is always to use two. Always use two. Why should you use two of these instead of one?
Not erase the content of the file. Do not erase the content.
Exactly. To not risk accidentally overwriting something that you might already have there. So always use two of them. That's a good security practice. And it goes the other way around, so I can redirect the input from the file. Now, do not forget that we can install Linux from the source. And shell is not an integral part of the OS or a mandatory part. When I create a distribution that is only mine, right, for a very specific purpose, I can choose which shell I want to install, or no shell. It will be difficult, but I mean, to manipulate, but it's possible. It's absolutely possible. So there are multiple shells that you can have, or none, and they can differ. This is a very small comparison. This is a very small comparison, right, between shells. This is just to show you and to give you the idea of the differences, because I cannot put 50 pages of this, it will be stupid, but look at it. Just look at, for example, some of the commands and differences here. For example, this is not even possible in Fish.
But is
Look
it
at this.
POSIX? Is it POSIX? Fish is POSIX?
Yes.
Is also POSIX? Because CSH, for example, is not POSIX. I'm
You
not
can-
sure. TCSH, I'm not sure it's POSIX. It's not standardized.
Now it's no longer, nothing is no longer a standard. That's the thing, right? Nothing is a standard anymore. This, as I said, is just an example of how difficult this can be if you rely on built-in tools. And it can be even worse, right, as you said now, right? They have changed a lot of things in Linux in the past time, right? Normally, when you would go to a Linux distribution, some normal Debian, doesn't matter, Ubuntu, one of the things that you will see as a part of the standard distribution is a C compiler, right? That's a normal thing, because a lot of things there are C++. What happens now? And you will see that there during the practical. You want to compile something, there's no C anymore, right? They have taken out stuff that used to be a standard for Linux. And if we do not prepare our toolkit so that it is functioning regardless of the distribution or regardless of what that guy who created this specific installation thought it's necessary, you will be in a deep problem. It happens a lot, right? It's also preventing some of the remote acquisition tools to function, right? Because they don't find a lot of results. That's why it's very important to have a toolkit that will meet all possible situations, right? And also for you to be able to find your way around in different environments. So, shell scripting, I also do some scripts with students when they have some time. Maybe I can give you some for data collection, simple ones, at least collect that initial volatile data, right? So dump all network connections, processes, so on. That's not a bad approach. Manipulating files, folders. This is something you can test in practice. This is explaining how commands work. I know that Reza likes to do a lot of ARC and similar things, so that's his thing. He really enjoys it. And diff, this is something that I will use now before we go to lunch. Last thing for this part of the session. Diff is one of the most important things that you can use to detect intrusions into a Linux system. Why diff? What does diff do? I'm pretty sure you use it, right?
Compare between two documents.
Exactly. So, how many of you here knows exactly what should be in a init D script? Probably nobody, including me. How can we actually know that that script is manipulated?
To compare it with the same system.
Exactly. And what do we need in order to be able to compare it with that same system?
Another district.
There is something that's basically true, but every company that actually does security properly will have something that's called the golden image, right?
Okay.
So, if this is my Linux server, it's compromised. The only way how I can really understand if scripts have been edited is if I have a golden image. Otherwise, it's impossible. Because so many texts, I have no clue what should be in that script. Even the admins don't know what should be exactly in those scripts. It is impossible, simply humanly impossible to do that. That's why the fastest and the easiest way and most exact way, it's the accurate way, is to have a golden image and you use diff, right? It will immediately tell you where are the differences and in which files. And you of course don't have any only important files, you don't look at everything, it's also time consuming, just those important scripts that we know that they're used for persistence and so on. So diff is gonna be your best friend. Again, it requires a baseline. It requires a baseline. Sometimes, even if you don't have the golden image, similar distributions still help, right? Because normally, there shouldn't be differences, especially during the boot process, right? Those scripts for the boot process, there should not be, it's not significant differences, right? So, we stop here. Let's make a break for lunch. And then you come back, we'll do the practical. Okay, guys? Cool. Then let's stop now. A very short time for an MSc inside the security. if you look at any job interview for cybersecurity, especially for something that is incident response based, right? They expect you to be like a Swiss knife. You know those Swiss knives with 50 different functions. That's what they expect that you should be a developer. You should know everything about networks. You of course need to know forensics. You need to know, of course, everything coming out of SOC, right? So in SOC analyst, you need to know security architecture. What else you don't have to know? There's nothing else left, right? You need to know absolutely everything. Do you know this a little bit of Python? Do you know a little bit of Java? Do you know about networks? Do you know about configuring firewalls? Right? That's very different. That's very different. That's why when we talk about this course also, what Reza did, and I think it's a good thing because it gives you the opportunity also to grow, is this is just a foundation, right? That's why we are more talking about the methodologies than specific tools, because tools don't really matter that much. And since everything is so limited, and Linux is one of the examples how things are extremely limited, because it's one day, we concentrate on things that you might actually need. One of the basic things that we do in incident response is acquiring evidence. And there is no complete task of acquiring evidence unless you acquire RAM. Unless you also acquire RAM. Unless you dump the memory. And I know that you had a memory course, right? You had it already or you will have it? You had it, right? It should be with Bobo, right?
Yes.
And he's really good. He's really good. Did you do that with Linux then? Yeah, I think he only does Windows. Never mind. And I don't want to make this overcomplicated for you. If you have some extra time, I will show you. Important part is the methodology. Doesn't matter if you're searching for stuff in a Linux memory image, in a Mac, or in a Windows machine. Methodology is the important part, and I'm sure you cover that. Because you should basically know what you can get out of RAM and in which situation. For different use case scenarios, you will search different things. On the other hand, dumping memory in Linux and in Mac is not so straightforward, and it can be problematic. It's also a problem with the profiles.
Okay.
Especially for Mac, this is an issue. Dumping and profiles are a huge problem. But I will explain this as we go. So what we will do now is we will deploy an EC2 instance. So a VM that's going to be a Linux based, and we will try and stick with our free tier limitations. Not try, we will actually do it. Let's select one. It should put this thing that we're talking about should work in any Linux distribution. Doesn't matter what it is. For Debian especially. This same method that we're using is used for dumping the memory from your Android phones. Exactly the same tool, exactly the same principle, because it is also Linux on the bottom of the operating system. And for this to work without any additional problems, let's all select one type of machine. I think a standard Ubuntu should be fine. I haven't tried this for the last 2 months when I taught this last time, but I'm pretty positive that nothing major changed in the past 2 months. You can of course select something else, like an Amazon Linux version, some Debian distribution of Ubuntu. You can just go with the standard Ubuntu one. Now, here you see free tier eligible. Just stick to this and don't worry. Right? Select free tier eligible and you're fine. As you can see here, with free tire, you don't have much choices, right? These are now more complex machines, deep learning OS, NVIDIA driver, all sorts of things are there. There are servers with SQL Server installed and so on. We'll talk more about these two instances tomorrow. I won't go into too many details now. This one is just now for this practical. Take which one you want, doesn't really matter. They should work the same. This one is 24, the other one is 22. If you select the 24 one, it should also be fine. So it shouldn't be a problem. Mine is still on 22. So I'll leave it to you to select. I'm pretty sure that shouldn't be any issues. Why is this also important? You will see that when we compile. Because dumping RAM depends on the kernel version. And definitely a kernel version in Ubuntu Server 24 and Ubuntu Server 22 will not be the same. But still, try this one. If it doesn't work, we will revert to the 22 one. So take the free tire one. The architecture can stay the same. Instant type can stay the same. It's very important now that you create a new key pair, which you will need to connect through SSH. Or if you want to connect through SSH. If you will be using it with SSH, take the PAN format. If you're going to use PuTTY, use the PPK. I'm pretty sure some of you are already using PuTTY, but in Windows 10 and above, you have SSH. You just have to install it, right? Do you know how to do that? And I would advise you to use SSH. It is, for Linux, this is the best way how to connect. PuTTY is also good, so everything works with PuTTY, but SSH is, for me, the best tool. Has any of you installed SSH in Windows?
No.
Because it comes in a package, it's already packaged in. Okay, then let me show this in the.
Okay. Okay.
Should be a very quick tutorial here. It's not enabled by default. It's not enabled by
I
default.
have SSH pairs in my.
It normally does not come by default.
You open SSH
It doesn't
server.
come by default. So it's there,
Because I have SSH.
it's there, but depends how they installed it. Depends how they installed it. Normally it's not. Check it out. It should be pretty. Let's find one for Windows 10. Oh, this one is in French. I think this should be. No, there's a built-in one.
You can just check in the operation.
Yeah, you just check. Yeah.
I found the OpenSSH server. I don't know if it's the correct one.
There is not.
I just found a feature here. OpenSSH.
Yeah, you install a feature. Yes.
Alright.
That's the one. But I want to put it on the screen as I did for the other people because it's easier that way.
C'est bon, t'as trouvé.
Ouais, non,
Ah, t'es
EC2.
sur EC2. Non, ça dépend. T'as Windows 10.
Donc, quand je fais des SSH, tu le vois.
Non, mais après, tu peux l'installer.
I think it's this one. I think the last one that I showed was in French.
Peut-être il faut
So,
Et peut-être l'appeler sur la Peut-être l'appeler sur la
if it's not enabled, this is how you can do it in Windows 10. Okay.
Non, tu choisis Ubuntu. Tu descends. Attends, doucement. Monte. Voilà. On peut d'abord, il a d'abord choisi là. ça peut voir ton taux de gratuit. Ensuite, sur son code, c'est bon, tu descends. Le type, tu peux laisser, tu
This
descends.
is-
Maintenant, là, tu vas changer.
This is something you can also do separate. Let's go back to the machine.
C'est ça où il dit utiliser SSH.
So create the keeper. Let's call this, that is, we have a lot of VMs on EC2 with different accounts. Now, what is important here is that you allow traffic from either anywhere, or if you will always use a fixed IP, you can put an IP here. We will shut down the machine anyway after we finish this, so it's not important, but in order to connect here with SSH, it's important that you allow the traffic. That you allow the traffic. At this point, there is no need to allow other type of traffic. We'll just dump the RAM, and that's about it. For the next exercise, tomorrow what we do, we will do it differently. As you can see here, there are limitations in this space also. Your FreeTire machine, look, it's up to 30 gigs.
Sir, I don't really understand what you want to do.
You want to deploy virtual machine, Linux virtual machine.
And is it compulsory to have SSH?
I would say yes, if you want to transfer files into and back from the machine. We will, for this exercise, we will use directly a link, right? But if you want to take that dump there, how else you will take it out?
I have already SSH in my Windows.
Then it's fine, you're
But
fine.
I don't know why
It's not
some
launching.
problem on.
You won't need it today, don't worry,
Okay,
don't worry,
thank you.
don't worry, that's all. And these are some behaviors, don't worry about that also, and you only have one virtual CPU for this instance. Those are the limitations of a FreeTire account. For testing and what we need to do for learning, you don't need more anyway. It's perfectly fine. So if you can do this, just select the FreeTire one and launch it.
Sir, can I see your configurations once more? Sir, can I see your configurations again, please?
Just, I would need to launch another one, because that's tell me what you need and I will explain.
I just want to check the configuration storage. I have 1 gig and the GP3 partition.
You can increase the disk size to maybe 20 gigs.
Okay.
That might not be a bad idea. If you're gonna use this machine for more than just this exercise, you might need a little bit more space. Other than that, it's fine.
All right.
Il faut mettre 1 giga à la machine et c'est tout.
Et après, que tu peux lancer.
You can launch
On
multiple
change pas la
machines,
RAM,
yes,
rien du tout.
but there is a limited amount of hours that you can run them.
Ok.
And the more machines you have, then the faster the time will run out.
Because this machine is free.
Hmm?
This machine is free.
The machine is free,
Yeah.
the machine is free, but the time is not free.
Okay, okay.
Right? You have, if I remember it correctly, I will need to check again, but you have, I think, 75 hours.
J'ai pas lancé, j'ai pas encore lancé.
Yes, and then it will start charging.
Yeah, but that's very low because it's the 3 micros. So
I know.
Some sense.
This is only for testing and learning purposes, so can't be more than that.
We have the key, we have the terminal, we have the ID, we have the user, we have everything.
Then, let's connect.
J'ai téléchargé la clé. Je vais tester ça, j'ai téléchargé la clé.
Oui, tu lances l'instance. Ah, c'est bon.
Tu repars sur ta machine, c'est en forêt. Je trouve que c'est pas possible. Après, c'est le calcul de
Now, there are multiple ways how you can connect, right? Some of them cost money, but you can try for free, like Session Manager. That's why we will skip that. An SSH client, which is a preferable way, right? Because with that you can do everything. And an EC2 serial console. So there are multiple things you can do here. You can see if the machine is now running. So as soon as it stops initializing, you can run it.
Connexion comme ça.
Il y avait deux types de cartes,
J'ai pas vu.
Now,
I have a little question. Do you advise us to use Ubuntu 24 or maybe it's better to use Ubuntu 22? It's more stable.
I haven't tried it yet, but it shouldn't be a problem. In the past, we also used the last updated one, and it worked. I will explain why this can be an issue while we do this, but you should not. I think you should not have that as an issue. If it happens to be an issue, we will launch another one, but I hope it will work. And I think it's important to test always the latest one. Yes.
I'd like to ask you, if connecting to instance, should we use electronic connection?
Yes, just use that one. No, use that one. Now, with the standard connection directly from the browser, you can work in the terminal. And that's not a problem at all if you don't have to manipulate files from your local network. If I would now have to take that memory dump to my laptop, that would be an issue, right? Because I would have to set some sort of a proxy where the file will go, and from there to my machine. With SSH, you can do that directly. We don't have to do that now. You just dump it because the process and explanation on what it actually does is the important one. But in forensics, if I would be now taking the image of this machine, I would have to put it somewhere, right? When I dump, for example, a full disk image, I have only two choices in a cloud. One is dump it directly to my machine, right? Yes. And what's the second one?
On another cloud?
What?
On another cloud?
Well, it can be in the same cloud, you just call it a different service, right?
Yeah.
In Amazon, it have to be an S3 bucket, right? In Microsoft And Google, they call it differently, you have blobs and stuff like that, but you have to go there. The problem with the other approach is that it costs money. Right? All those things cost money. So this is the fastest, cheapest, and I would say also the most forensically sound approach. So, what do we do now? And you have the commands here. We will use git. If they don't have git, we will add git. They keep changing the default commands, so I'm not sure what is available.
I don't know why, but we don't have something that moves when we connect it to
You don't have to have the same thing, doesn't matter. It's perfectly fine. And you shouldn't all have the same thing. It's all good. It's all good. So, let me see also what they have here. And I will.
J'ai pas eu le temps de coder là.
Il n'existe pas. Sur ce que je veux d'accord. Non, j'ai rien.
So, I have tested this last night and I have done the RAM again.
Ah, voilà.
So I will just quickly delete it. And I will install a new version of Lime. Actually, I will use it here.
Mail, ça compile le fichier
Now things change depending from the version that you're using. Sometimes they had some tools, sometimes they didn't. Amazon often changes the default tools in the machines. So try Git. If it doesn't have Git, we'll just install Git with apt. So no problem. If this doesn't work, install it. Give it a try. Let's see if it's here. Yes. Now.
Lime is used for to copy the memory or the hard disk.
Memory.
Okay, memory.
I will not do a disk image because that would be pointless.
Because I have a question for the hard disk. When in Linux, when you use DD, you have to copy all the hard disk, or you can just copy the hard disk that is used.
You mean logical acquisition?
Yeah.
DD is a very flexible command. You will see examples of different approaches to DD in one of the presentations that I will do in the afternoon. But it is done for physical imaging.
Yeah.
You can avoid that by saying, okay, give me only these sectors, right?
Okay.
Start from sector 0 and then here. But that's neither a good or a reliable way. Right? If you're doing DD, then you won't be visualizing.
Because in my work, I use one time DD to transfer to migrate the machine over a server, another hardware. But I had to wait all the time, so it's very long.
Yes, because it's reading files differently. It's reading files in a different way, right? It's literally reading bit by bit.
Yeah.
It's bit by bit. And every tool that does it that way will be slow. You also have to ask yourself, does it make sense to do a physical image.
I had a lot of service, so
We will discuss this physical imaging later today, and I will explain why and when does it actually make sense. And then you will decide how you want to proceed. I will give you my point of view from my experience, and you will look into. Now, what we have here is the source code. Look at it here. This is a C code that needs to be compiled. And you have the command here. So this is very simple. This takes just a few minutes if you follow the steps. You just go to the folder, so CD, into line, source, and do make. What is make? Why does it work? No, because they now with default versions of Linux have taken out the default C compiler. There is no more a default C compiler as a part of the distribution. That's why. Did you compile? Compile the code.
Il veut pas cloner moi le.
Don't
Le lien, il est un
jump
problème.
to steps. I will show you. So we downloaded. We went into the folder, and now we compile. So this is a source code. It has to be compiled as every other. This is not a scripting language. This is something that requires compilation, right? This is C. And look at the output. Now this is important.
moi j'ai des erreurs de.
Non, mais il faut installer le mail.
Look at the files now. Did you have this file before?
No.
If you don't have make, let's install it.
Okay.
If you don't have make, we will install it. Just tell me that you don't have it.
I don't know.
Moi l'URL il marche pas.
Je t'ai envoyé un lien.
If it gives errors, it will be because of a missing C compiler. That's going to be the reason. Missing C compiler.
C'est compile.
I told you if it doesn't work. So this part you use if it doesn't work. No.
En fait, il est installé. Pas besoin de le faire, mais s'il n'y est pas.
Don't do that. Because it's not the same as
Je fais pas avec un jeu compilé.
That's why I like to use.
Non, mais moi, s'ouvre la flèche.
See, this is your
Après il faut aller dans CD
Tu fais un make là-bas.
j'ai fait une connerie. Il faut aller direct
Fais LS. See the line.
If it doesn't work, on the top you will have an error saying GCC is missing, which is a C compiler. So you write this. Okay. What's not good?
It's
Non, non, en fait, regarde, il écrit bien. If it does not work,
Ah oui, il y a
ça fonctionne, le clip.
Oui, non, ça je vois.
Il faut avoir.
Oui. Oui. Ubuntu.
I was assuming that you know, and that's a problem. You should know. No, I did make one mistake. I made an assumption that you have standard experience, right? Which is not always the case, so that's purely my fault. What is the first thing that you do when you install a new version of Linux? Sudo update. Right? You first update the repository so that you can install tools. That's the first thing we do, and I was under the impression that that kind of is known, but that is purely my fault, not yours. So sudo apt update for those who have not updated first. And let's check if it works for you guys. Yes. Version 5. Let's see what they do. Yeah.
Alors là, il tirait 6 AWS.
Just tell me what you did in that room. That's why I'm here. So, what is it?
C'est quoi ça s'appelle la liste? Lim.
You already did one. You already did the repository. You don't have to. This is forward.
What's the code root sur Ah, c'est les bonnes, c'est vraiment ça sert. Des fois, il y a des trucs comment monter une infra.
Is there anybody here who was not able to compile the source code?
Hi, sir.
Let's see
I
what's
have
up.
a mismatch in GCC versions.
Let's see. First of all, let me see what you did.
I first installed did an update and upgrade, then I did back.
You did upgrade.
No upgrade? Okay.
Did I told you to do upgrade?
Sorry?
Did I told you to do upgrade?
No, sir.
Upgrade changes the kernel version. Now we have a mismatch. That's why we have a
But I
mismatch.
had it before. Alright.
Don't stress.
Okay.
Fuck it, it's a VM, right?
Okay. Okay.
Did you compile it? You're still installing GCC. What? It doesn't let you If you can compile, it will work. Well, that's what you will create. I will explain.
Sorry?
Yes, I was about to say. Now, let's just listen to me for a moment. Do ls in your folders. Yes.
Okay, it's good. Sorry, we installed the GCC and make, but it equals doesn't work.
What does it say?
Default error.
Go back. What's wrong? We don't have all the same sheets, so I don't know what to do. Now, for those who have compiled it, you have this file. Is it the same like my file? What does yours say?
I have version 6.2.
Perfect, good.
6.8.
Good.
1020.
What is this file? What is this? These numbers.
C'est le kernel. Le kernel leader. Version.
Exactly. Do you know how to check your kernel version?
Unnamed. Unnamed-h.
Try uname A. Do this. Let's all do this together. And look at this. This is the same thing like this here, right? If it can create this file, and this is not a normal file, if it can create this file, it can dump RAM. Also, if it can create this file, it means that there is probably a volatility profile for this version of Linux, and you can also analyze that file. Otherwise, it's going to be a problem. It's not just that you cannot dump RAM, you cannot do anything with that file itself. There are still other ways how to circumvent that, but it's not working more or less to do it.
Is it a profile of
So, there are some security features in Linux that prevent you from dumping the RAM. So by default, they don't like you to dump RAM. In Mac, it's even worse. The limitations in a Mac are extremely complicated. So if you think that this is complicated, wait until you see in the Mac. I don't know who's teaching Mac, but I guess they will show you how to do it. This thing that you see here is not a file, like just a file. I mean, it is a file, but it's not insignificant file. It is something that's called kernel object.
Module.
Yes, in
Module.
in Mac actually they call it kernel module. So it is a specific type of file that needs to be pushed into RAM, right? To be able to have permissions to access the area of RAM that we need to dump, we need to push this kernel object into memory, right? Other than that, we cannot access the file itself because, as I said, in the past, RAM was just a file, right? Copy, paste, that's it. Now it is a protected area. So we need to circumvent those protections to avoid those restrictions, and this is the way how we do it. There are also some other tools still functioning in a similar principle. They will give you sometimes a different output. Sometimes they are easier to use. You might not need to do all these steps, but they might not be able to do it in the first place. This one will for sure do it. If it's possible to be done, you will be able to do it with Lime. If it's not possible to do it with Lime, you won't be able to do it with anything. Look at it from that perspective. And this is also the same tool that they use for dumping the memory in Android phones. Right? The next command that you do, is actually pushing the module into memory. So sudo insert module. As he said, this is a module. So insert module Lime. The file here, that's why I left it here, should be the one that you created. It should be your kernel object version that you compiled on that machine. And the path, you can put whatever you want. There are different formats that you can use. It is also very important to know what you want to do with this RAM. If you want to analyze it with volatility, if you want to analyze it with recall, if you want to analyze it with redline, do you use redline?
No, sir.
You done memory, didn't do redline.
No, we did X-rays and autopsy.
For memory. For RAM analysis.
No, volatility, just volatility. Just volatility, sorry.
You should try to avoid this. When I had another class just 2 weeks ago, because I'm not teaching only here. And what I gave to the students, because we have more time, as much here as possible, there's an entire scenario, right? So you get an infected machine, you get an alert from CN, like in real life, and then you have to investigate what happened.
Right. Just question about the path on can create.
I will explain it. Okay. I will show you. I figured that some of you will have it.
Laboratory test.
Whatever you want. Whatever you want. You can even dump it in the same directory if you want. You dump it in the same directory if you want. When we do it with them, they have a memory dump. Yes. And they have to actually recreate what happened in that machine. It's not just a memory dump. It's also a full machine, right? You have memory, you have disk artifacts, and so on. If you would have to do that just with volatility, I'm pretty sure you will not find at least half of the evidence. Right? So my advice, I don't have the time just to show that you should have, in the police they do it differently, right? I know when I was also working in the police, the way how you work and and the data that you're searching is a bit different, right? It's all about, finding a certain file. Did this guy have a video file picture? Was there a message sent from this machine and so on? In corporate environment, it is different. It's different, and often you have not one, you have 20 inspected machines. And if you look at them partially, like that, volatility. Methodology is very important for instant response if you work in any private sector. Okay. Those who are penetration testers, I guess you do those type of attacks where you try to exploit whatever you catch, right? So you do probably not just standard stuff like exploitations and privilege escalations, but you also do some lateral movements. Correct? From the perspective of you as an attacker, right? Are those machines separate evidence, or that's all part of one single attack? So if you're a hacker sitting somewhere in North Korea, right? For you, that's all the same thing, right? You came from one machine and another and so on. So if you want to understand what that guy did, you have to look at it from his perspective. Not from the perspective of forensic investigator, from his perspective. And still, although very, very rarely now, people are still examining single devices instead of all devices at the same time. When we do it, we examine all the devices at the same time. That's why red line should be you should do memory forensic first with red line. And then, what you cannot find, then maybe you turn on volatility, not the other way around. But we can talk about it later. Now,
I can't do the listening on the port 555.
let's insert this module. Let me find where I did it last night. So I have to retype again, and I want to show you something. Now, the path can be whatever you want, including this own folder. So if you don't want to create other folders, just dump it here. Okay. Just dump it here. These machines have only 1 gig of RAM. This should take 10 seconds. Not more.
Madame, le path, en gros, c'est le fichier que tu vas créer, c'est le dump de la M. Quand tu mets le path directement, ça veut dire que tu vas en folder.
And it's done. And let me check.
Ouais, j'ai le dump là. Avec cette commande, avec le sudo mode, ça permet de line-de.co.
And there it is. Look at the file.
Voilà, un dump qui apparaît.
1 gig.
Yes.
And as you remember, when we created this machine, it gave us only 1 gig of RAM, port 3.
C'est un timeout égale 0.
I will repeat the command. I will repeat the command. No problem. Let me put it on top. This has to match your kernel version. This has to match your kernel version.
En même temps, c'est marqué au tableau.
That's what you will create. You can call it whatever you want. This thing, this, you can name it whatever you want. You can call it Mickey Mouse. Doesn't matter. This is your memory dump. This file that you're creating is your memory dump. It doesn't matter how you call it. I called it mem because it's just memory, right? But you can call it whatever you like. I don't care if you call it Strum. Now, Is there anybody else with problems?
I have problem, but with the next part. To listen and the part.
No, this will not work. You can actually do this with SSH and so on, or if you do this locally. Then open one terminal. You can also open several terminals and then from one terminal to another send this. But
That's okay, like that. If we can
it's okay. I will explain. I will explain. Now we will talk about what's important. Okay, so the methodology part is now what is important. Okay, this is a technical part of data collection, right? It's mandatory. This is a forensic step that we really must have, right? You will also see that a lot of remote acquisition agents, like for example Nuix agent, there are also some endpoint agents such as the one that FireEye had that can also do on-prem. They will not be able to do this either completely or partially from Linux. So if your company is using, for example, Defender as an endpoint agent, he can't do this, right? You have to do it yourself. Also, for example, Nuix is a forensic agent. F-Response, you heard about F-Response, for example? They're also forensic agents for remote data acquisition. Why? Because I'm sitting here in Paris and the victim is in, I don't know, some Martinique, right? Probably they will not pay you to travel to Martinique to get a memory dump. Unfortunately, I'm sure a lot of you would like it, but I know when we had an incident in Madagascar, and I asked who wants to go, everybody volunteered. So, but that probably is not going to happen. Plus, it's not efficient in the middle of incident that you wait for somebody to travel to Martinique and bring you an image or a RAM dump, right? That's why we have these forensic agents. But these forensic agents work pretty good with Windows, with Linux and Mac. It's a problem. It's a big problem. The biggest problem with memory is exactly this part. This part. Even a single change in the kernel version makes an issue, which he saw, right? He did Linux upgrade. He did apt update, but also did upgrade, and the thing crashed, right? So every single, the minor change will cause the tools to fail. That's why you pay a lot of money for it, but it still doesn't work. So we have to rely on our knowledge. That's why I want you to know how to do this, because you will be, in a lot of situations, this will probably be the only way how you can do it. But the way how we did it here today, what you did here, is completely wrong. And it's wrong for several reasons. What is very important is that you explain to me why was this wrong? What was wrong here? Just from your experience, what do you think was wrong in the approach that we did it here? So without the RAM, that's not a wrong thing, but everything how we did it is wrong. So why is this wrong?
Permission-wise, we didn't have the authorizations.
Authorizations are important. That's a very important aspect because this requires root privileges, right?
Yes, sir.
That's an important thing. But don't forget you will be doing this in your own environment. So you will be dumping RAM from your company machine. You will not go to the room next, right, in this library across the street. So it is expected that in corporate environment, you have the permissions.
Okay.
You should normally not have a permission issue. But that's an important aspect. Although here, I would say That could be a problem maybe for the police when they're going into a search. For you guys, not that much. But yes, if you're not doing this in a corporate environment, that is an important aspect, and I agree, it is not a wrong thing.
We are modifying the RAM by accessing from the machine and doing the.
There is no other approach. And that's unfortunately unavoidable, but
Okay.
what you will do, I'm also a court expert, right? So when there are some, they call you for a court testimony, blah, blah, doesn't it? And when lawyers are trying to say, you know, but you did this, you made a change, you made those kind of things, you have to know what you actually changed. You have to know what is the footprint that you left.
Okay. Yeah, cool.
Sometimes it is unavoidable to leave a footprint. It is important, first of all, that that footprint is the smallest as possible. So instead of size 48, try to wear 35, right? Some kid shoes. And try to understand what did you actually affect. But there is something else that's also important when it comes to altering evidence that was much more relevant to this. But let's see what he has to say.
You made a copy of the map?
He made a full identical copy of the map. That's what we actually did. We made a full identical copy of the map. But what didn't we do right? That's the thing.
I think we altered the versions of software installed by
We didn't.
with the update.
That part is actually true, but let's formalize it in a little bit different way.
Okay.
We have to avoid pollution around, make sure the machine is isolated and the minimal
Isolated.
isolated, and there is a minimum program executed on RAM.
That is important. That is absolutely important. That is also not a wrong. Is also not a wrong answer. But let's look at it from this perspective. We came here in this exercise making assumptions, right? And assumptions, you know that they say when I was teaching in US, they often also used some of those trainers. Assumptions are the mother of all fuck-ups, right? That's actually true. You make most of your mistakes by assuming that something is true or not true. It's there, it's not there, right? And we made several assumptions that in reality will probably not be true. First assumption, as he said, is that we have root privileges. In corporate environment, you will actually have them. Because if you cannot administer your own devices, then what are you, right? If you're in the police, then that assumption is actually problematic for you because you might not have it, right? If I go into an organized ring, right, they have those boiler rooms where they call people and they often use servers and stuff like that, different frauds, they probably will not just give you a password for the server. So that can be an assumption that's wrong. So since you might have people that might work in the police, let's also use that as an assumption. Those who work in companies, it's not an assumption for you. It's a fact. You have root access. But let's cover all the angles. So first assumption is that we have root access. We might or we might not have, right? What is the second assumption? Second assumption is
It's a real machine. We don't know exactly what is a machine.
we should normally know what is the machine, right? Because the data center should tell you, okay, this Linux, it's used for a database, and right, we keep those kind of data. You should have that inventory. If you don't have it, then probably you don't have any other security. Companies don't have a basic inventory, then what kind of security they can have, right? If I don't know what I'm administrating, how will I know what to protect? So that's the part that you should normally know about. What we did here is, where did we dump this image?
Ah, okay, on the cloud. cloud space.
No, we dump it on a hard disk.
Okay, on that
The fact that this hard disk is in a cloud and it's virtual is not important. It is still a hard disk. There are two things wrong with dumping this file on a disk. One is forensically wrong, the other one is an assumption that we had that's also wrong. What are those two things?
The file system of the hard disk is compatible with the file system.
It will be always, no, that will always be compatible. Don't worry about that.
On the forensics point of view, we are compromising the evidence. Or by we are automating.
Compromising, not, but
Polluting?
something else, yes.
Polluting?
So it's what he said in the beginning, right? When we dumped this file on the disk, we have overwritten 1 gig of space. That 1 gig of space could have contained something else. And I'm talking about this methodology in general. Doesn't matter if you're talking about Linux, Mac, or Windows. You should keep this as a rule, right? So when we dump this, we overwritten some files. With this modern hard disk and the limitations that they have, it's a question if it doesn't even make sense, but still it's a forensic rule that should be respected. But more importantly, don't forget that in real life, if you're dumping memory in Linux, you will be probably dumping it from which type of device? No, type. I'm talking about the type of card, right?
x64.
It's probably going to be a server, right? I don't think you will have a lot of Linux clients in your environment. There might be some, but most likely, if it's a compromise, so it's an incident, and you have to dump the RAM, it's probably a server, right? In hacking cases, it's normally a server. What is very standard things for a server when it comes to hardware configurations?
Very huge amount of capacity.
Yes, so a lot of RAM, and not that much disk space. Unless it's used for actual file storing or some databases, the servers have to perform a function. That function normally requires speed and stability, which means that there will be a lot of RAM, and it's going to be an ECC RAM. Don't forget, there's going to be an error correction RAM, which can also have influence in dumping the RAM. It's not the same thing. ECC RAM and normal RAM are not the same thing. And you should know how to analyze that. Because it doesn't matter if it's Windows or whatever. The ECC RAM can sometimes cause issues because of the parity bit and shit, right? Control.
So you said ECC RAM and?
Normal RAM.
And normal RAM are not the same.
Okay.
Servers take ECC RAM. In my laptop, this is Excel, I have an ECC RAM. And trust me, it makes problems. So, when I dump this, what have I assumed? I have assumed that I have sufficient disk space to dump that RAM. And imagine that this is a real life situation. And you have 128 gigs of RAM, which is a standard now. We have servers with 512 gigs of RAM now. Easily. How do you know that you have half a terabyte free to dump that RAM?
DF, comment? DF.
You can check if I don't have it in the first place, right? It is not uncommon, as I said, that the servers have more RAM than disk. We have a lot of servers which have a terabyte of RAM, but only 256 gig disk inside. Maybe it's going to be probably several disks because they're in RAID, but the total space is 256 because they don't need more, right? Because they are running a webpack. They need speed. And they need to be accessible, right? They don't have to host movies. So very often, your RAM will be bigger than the disk. So when will you dump that? How would you solve that issue? There are two ways.
We
right?
mount a file system.
Hmm?
You mount a file system. Managing.
But how do you mount a file system here, for example, in a cloud environment? You can, no, you can. There's a question, how do you mount? I already said, in this environment, in the cloud, two solutions. One, dump it directly to your machine through network. That's why you have those commands extra there. Second one, you mount an additional storage. In AWS, you have to mount an S3 bucket to this. And instead of dumping it to a disk, you would redirect the output into that S3 bucket.
Okay.
Then you have to pull it back. The problem with cloud, you will see that tomorrow. I will explain that and I'll probably repeat it multiple times. Everything costs money. Every single bit that you transfer in one or the other direction will cost you money. That storage that you take extra, that you pay, is going to cost. Transferring it from that storage somewhere else, it's going to cost you, right? Because it's going to take part of your bandwidth, right? So, in the cloud environment, either an additional storage such as a blob or an S3 bucket, or we transfer it directly to a machine. Also, you have another option if this is a data center, right? Because not everything will be in the cloud. Then you can just send somebody, if it's somewhere close to you, right? You can tell somebody, okay, go there, put a USB and run it from there. That's another thing that we assume. What is one more thing that we assumed when we did this? What else was necessary when we were doing this? And you briefly mentioned it also. You also assumed that there are tools that can enable us to run this, or that there is internet access available so that we can actually download these files that we needed, right? So we downloaded an entire compiler and installed it. We had to update the repository and all those things. Right? That required the internet access. In a lot of situations, this machine will be isolated, right? It will not be isolated from your internal network, because you still have to transfer the data. You still have to examine. You still have to do imaging. Not just the RAM, you also have to image it. Or take some artifacts, logs, whatever. So you normally isolate it from the internet, put it in some DMZ, right? So it cannot contact other machines in the network, but you can access it. That's a normal approach. And even somebody will ask you, would say, yes, I will take it and put it into an isolated space where I can access it, because if nobody can access it, how you examine it? Which means that installing C++ compilers is probably not going to be possible, right? Updating repository, not very likely, correct? Also, don't forget what we talked in the beginning. We rely that this is a default bash. The default binaries inside in the bin folder, so that we can execute all these commands. This might not be true at all. And it's very often not true. That's why these tools that you buy, the forensic agents such as Bluix and Affix-False, they fail because they are made for standard environment. And the environment is often not standard because I have created a dedicated server just for UTT to host a website. And that's it. So I shut down everything that shouldn't be opened, and I didn't install nothing that is really not mandatory, right? Because I wanted my full installation to be 200 megabytes. How would you now solve this challenge? Or let's say it like this. You're an incident responder. You have an alert. Somebody tells you there was a potentially infected server. You decided to do an analysis. You have to collect all the evidence. You start with volatile data, which is including RAM, correct? How would you approach this? This is almost the very first step of your investigation, and you definitely don't want to fuck that one up, right? Because if you make a mistake here, then everything else will just fall apart. So how would you solve this? You have this machine in the cloud, and cloud is especially good because it's much easier to do some things. Doesn't matter exactly what, I will leave that part to you. And they call you, they said this is in the cloud. It's, I don't know, they think it's maybe some APT group, like Cozy Bear or whatever, and you want to start examining. How would you approach this and not repeating the mistakes we did here?
Okay.
What would you do to not to do the mistakes that I made here?
I will first research on the tactics and procedures of the APT group, then try to identify based on the research.
That's fine. That's what you will need when you dump the RAM, when you take the disk image, and then you're looking for specific IOCs belonging to that group, right? The IOCs belonging to the group, we can search only once we have the evidence. But you still haven't even acquired the evidence. So how do you acquire an evidence? It is a machine that has only 20 gigs of space. There is 120 gigs of RAM. Even if you want to, you cannot dump it there, right? Plus, if you dump it, then you cannot do a disk image. Then what's the point of a disk image? You cannot install additional tools in that machine because you cannot connect to the internet anymore. How would you resolve this? What would you do to prepare yourself to be able to dump this without forensically compromising this machine?
There is no possibility to start another server with all the tools we need inside to make it communicate with this server.
You have to push the kernel directly from that operating system.
You can make clone this version,
Very good. And what then?
and we need regulation. We need the rules that are broken. What we did, but in the 7 PM, we did communicate with the internet, so we messed up.
You don't even have to go that complicated. What is a very good thing with the cloud? You can launch as many instances with identical settings as you want, right? If I have now this latest Ubuntu 24, right? And here's one is infected. I can just go there on the market and launch another one with the same operating system version. And I do all these things that you did here. I download a compiler, I download a tool, I compile it directly on that machine. Because I have to push it from that machine, but I don't have to compile it from that machine. The module that we have to insert, this kernel object, has to match the kernel, not the machine. It does not care if it's compiled on this laptop, right? It has to match the kernel version of this laptop. So anything with the kernel version 6.0.2117, right, will work on any other kernel version of that same type. So yours will work in his will work in hers, and so on. So with cloud, we have that flexibility that we don't have in a data center. Still, probably the data center will not have only one machine with that version of Linux, and you should still be able to compile it. If nothing else, you can download ISO of that Linux and install it again. It just takes a little bit more time, right? But the answer is create a machine in whatever way you want. as a clone, launch another one, doesn't matter. With the same settings and compile that kernel object. Connect with SSH. Connect with SSH. Push that module as we did it here. Immediately the command, send the output, so redirect that through network into location that you have, either an additional bucket, a remote machine, right? You can use Netcat for this. Netcat is perfect thing for this. With Netcat, you can also dump the entire disk through network. Yes, yes, yes. That's why we have those things. That's why we have those things. And with this, first of all, you didn't rely on any tools on that machine, which you may or may not have. You don't rely on having the internet connection, because I could have isolated this machine, right? It will be still on the internet, but it will be in our own virtual cloud, right? VPC. In that VPC group, only I can exit, cannot go on the internet. And finally, we didn't think how much disk space we have, right? And you didn't overwritten anything on the disk. So that would be the proper approach for this. Also, but you should be very careful, and this is again an important methodology pointer, is at what stage and how do you isolate machines for forensics. Often we ask the candidates for open positions based on a scenario, right? That's why I said also when I do with the students, we have a very long scenario. They have to investigate everything. What happened, starting from the alert, the CM, and so on. If we had more time, I would be very interested how you guys would do that. But let's say it like this. In this scenario, you're that incident responder, right? And they told you that there is this infection, potential infection, right? Or let's maybe even make it more simple for you. Not that it's potential, it is confirmed. The guy calls you and says, I have a ransomware on this server. And he knows that it's a true positive alert, they have a hash, they know that it's some version of ransomware. There is thousands of them now, I guess. Currently that ransomware is doing nothing. Right, so they know that there is a file there on that Linux server, and especially they like Linux servers because they know that they are important, right? You don't have a Linux server for nothing. And he asks you what to do. So what do?
You have to check the impact of this ransomware.
What do you have to?
If you isolate the server on your decision.
I'm asking you, what would you do at that point?
If there are no impacts, if there is ransomware, there's no impacts, I will not isolate the server.
What would you do?
It depends of type of server. It's not the.
We can put that aside now. Let's say you don't isolate,
Okay.
which is perfectly valid, right? You always have 50-50 chances there, right? So it can go both ways. You don't isolate it, then what you do?
Check IOCs from other machines for this for propagation.
Perfect. So that would be a smart approach, right? So isolating it as a first step, that's a wrong approach. Surprisingly, most of the candidates would say we isolate the machine,
Propagation.
right? What would happen if I just said isolate?
And maybe taking other actions.
Probably in another 20 minutes they would call you and say, okay, now I have another 30 servers. But this time, ransomware is encrypted. Why is that a serious possibility? Because most modern malware, especially this advanced malware, and most of these ransomwares that you have are advanced tools. Now they sell them as business. You know, you have ransomware as a service. You heard about that? They sell ransomware as a service. So it's like infrastructure as a service and sell ransomware. Those are context-aware malwares. You know what is a context-aware malware? Context-aware malware is malware that is aware of the things that are going on around you. Right? So, for example, the moment that he sees that he has lost the communication with the command and control server, he will trigger an alert and start doing things. About 10 years ago, maybe a bit more, I was still working in the police, and I was a 24/7 point contact for my country. They have it also in France. Just in France, they have more people because there are more requests coming. It's a special G8, then it was that time it was G8, now it's no longer G8, thing that was established. It's like a sort of I don't call it as a, not even a CERT thing, it's a cybersecurity point of contact in case of a major incidents, right? Big countries such as, for example, the United States, they have an entire service in the Justice Department. There are some things that can be important for investigations. Since Linux is still, for most people, less familiar than Windows, always try to approach these investigations by looking, okay, if I have this type of incident, what type of artifacts would I search in Windows? If you are familiar with Linux, if you know Linux very good, then I guess you don't have kind of a question, but from my experience, most people doesn't have so deep experience with Linux as they have with Windows. They will know Windows in more detail, they will know the artifacts in more detail. So it's always good to make this comparison between Windows and Linux. And there are multiple artifacts in Windows that we see as important, for example, especially in this situation we discussed about intrusions, right? One of the persistence mechanisms that the attackers are using for Windows is running services, right? Having your malware run as a service. I'm sure you heard about that or you know about that already. The equivalent of a service in Linux would be Daemons. Perfect script for a school. Perfect. So this would be an equivalent of Windows services. The same way, like the attackers are using Windows services, they can do with a Linux machine, right? So they can create a daemon or a background process which will be malicious and run as a service. That process can encrypt files, it can exfiltrate data, it can open a backdoor, it can do a bunch of things. But what is important is that it provides persistence. And why is it providing persistence to daemons a good idea? Because look, they are usually a part of the boot process. That's why I told you have to know the boot process though. They're not assigned to any terminals, so you don't have a user, you don't have a look. Just this data. That's why one of the approaches in examinations is to understand which daemons we have running. Same as in Windows, right? We look at the services running and see if some of those services are potentially malicious. The functionality is the same, the purpose is the same, and they abuse it in the same way. That's why you should probably mark somewhere on your list. The daemons are one of the ways how they can gain persistence. Processes, as I said, that's a standard thing. You can list them with a PS command. You can kill a process with a kill, and so on. I will go into that. You can do that on your own. What is important from the security perspective, this is probably what you already heard before. It's these files. The etc password, shadow file, group file, services, they all have important data. And don't forget, these files also have a backup. Remember, I think they told you this already.
Yeah.
There is a backup of these files. Often in investigations, it will be good to do a diff between the old file and the current file and see what has changed. Always do a diff. See what are these now new users, see who are the new members of groups and so on.
Yeah.
You should always do that. So diff, as I said, is your friend. And the fact that they have a backup is not without a reason. So check this is security important. The other files, depending of what they do, yes.
Can we force a backup? Can someone connect to the VM force a backup? So
Yeah, you can. I mean, you can do whatever you want. You can say, okay, every week you create a backup and send it to our storage, right, for a safe location. You can do that.
what I meant, if I'm an attacker and I manage to force the backup, so we can eliminate the difference between both files.
You can, yes, so you can do that. I mean, that in Linux, I wouldn't say that absolutely everything is possible. Most things are possible, right? It's just very flexible system for those kind of things. Now, etc host file. Do you know what is a host file? Hosts file.
This
Yes,
is
yes.
the machine.
So that's
the name.
That's the beginning of the internet, right? At the beginning of the internet, they didn't have DNSs, so all the addresses were in the host file. And when you type google.com, the machine doesn't go to the internet, it first looks at the host file.
It's a DNS profile?
Yeah.
Fine.
Yes. Because as I said, at that time, it was only possible to be done locally. What they did in the past, a lot of attacks was, especially these man-in-the-middle attacks, was done by editing the host file, right, and changing the address. Now it's probably not going to work with SSL and everything, but still they can manipulate files locally. Right? They can redirect users to a local service which they maliciously run. The host file is still of potential interest. We always check it. Hosts allow and deny, this can also be potentially important. As I said, some of these files, they are less important, just not because they cannot contain important data for the investigation, but you probably don't check it in every occasion. There are files that are not important for every scenario of intrusion. But these first couple of files, they are definitely something that you wanna make sure that it's there. So terminals that the root can log in from, you might want to compare. If you found that the root is logged in, you want to compare if he's really logged in from some of those terminals that he's allowed, or from somewhere else, because it might be that somebody remotely connected and hacked basically the system. Syslog, authentication log, I don't think that requires any additional explanation. How to set up a network, I don't really want to do that. It's not that important. Kali also has a forensic mode, and I know you probably already have Kali on all your devices, right? It's used a lot, and it can also be done for forensic because it can mount file systems in a read-only in a read-only mode, right? So this is a quick thing from this presentation, and I don't wanna waste too much on that time on that. As for the logs itself, also very quickly, you should just be able to understand the format, how they look. Is an important, all the important ones are also these web servers, right? This is a standard Apache log. You should be able to know how to parse these things, at least to recognize them, if not parse them. LDAP log, what is LDAP?
C'est the name of the user of the.
It's sort of a Linux implementation of an AD, right? So, but yes, it's for authentication. It's for authentication, LDAP server. There are multiple parts of Linux operating system that generate logs. syslog-d, klog-d, that's for kernel logs, and different software such as Apache, SQL can generate, and so on. These are some of the more common logs, like daily message. Surprisingly, people often omit the message of the day, but it can contain some very, very important data there. It also contains a lot of USB events there. So I would advise you also to dump that one. Mail log, cron. Cron is also something that you should investigate, and I will mention this also a little bit later. Cron, what is the equivalent of cron in Windows?
Scheduler, task scheduler.
Task scheduler at command, right? So this is a scheduled task thing. Scheduled tasks, also in Windows, are often used as a persistence mechanism. Also often omitted, the investigators forget to check if there are any scheduled tasks. What the attackers will do often is, if I leave my malware running constantly in your machine, and you go to your Linux server and you see, okay, look, there is now a network connection going on, right? Or you will see something in the firewall constantly beaconing, because beaconing behavior of malware is something that we are trying to detect and monitor. Because beaconing is one of the indicators of malware. It is a common behavior of malicious tools, right? Because you're constantly sending packets to a command and control server. Since attackers know that beaconing and proxies that are constantly visible are much easier to detect, what they will often do is they will say, create a scheduled task that will, for example, run a cron, run by cron, and in turn it will run another daemon, which will run from 2 a.m. to 3 a.m. Right? Because everybody's going to be asleep who's going to be working now in your company at that time. It leaves them the time to do whatever they need to do, plus it's not constantly in your logs, right? They don't see a machine 24/7 trying to reach one same IP address, because that's not a normal behavior, right? There is no service in your laptop that is 24/7 sending the same packets to some IP address in China. Since they know that they use a lot of these scheduled tasks and cron, so always check cron jobs. Mail, again, if this is a mail server, it would probably be an important artifact. In authorization privileges, you want to check the var log secure, right? This is one of the key logs that you have, because I want to know who authenticated, how, privilege escalation, and so on. This is from this log, so this is the one that you definitely want to check. Now, UTF-8, a little bit different than the other logs. First of all, it's not a text file, it's a binary. So it cannot be edited, which is good because it means that it's very reliable. Also, it is probably one of the rare logs that is not in var log. It's in var run. And UTMP will give you the users with active session, which means if I constantly monitor UTMP, I will know when the attacker is logged into this device. Because if I have a session, it will show. Right, so it's a very usable log. Last log is the information on the last login of each user. Again, if I'm identifying which users are potentially malicious, I want to check. And if I see that, I don't know, he logged in yesterday at 3 in the morning and he works in, I don't know, in financing, in accounting, in Paris, it's probably not the time that this account should be logged into this device. WTMP, it's all information regarding login and logout, any remote connections. So it will give you also the locations. I would say also very usable. And now these logs are really the most important ones. Last one from this most important group is the boot log. It contains the information that you will have during the system boot. So kernel boot script services, it's also showing you which services are started during boot. So you might want to check if these services should actually be there during boot in the first place. That's why I said services or daemons are what attackers are using for vulnerabilities as a way of establishing persistence. Now, what are the file names? You have the cron file, that's for cron jobs, daemon log for the daemons, kernel log or kernel log, xorg, X, that's for the X server, so the graphical server, Anaconda log, Yam log, and so on. Samba, if you have it, MySQL, there are different web types of logs. The bash history is not a log file per se, right? But it's quite important because it can contain the commands from the attacker. And don't forget we have history file for every user. So when examining history files, you should check the root history file and every user's history file. Because you don't know in which context he ran the commands. So if he was running the commands in the context of the user, you should also check the user history file. This log configuration file is the control of the behavior. This file basically is telling us what will be logged, when it's logged, so the level of logging, right, critical and so on, what kind of action should be logged, depending on the log type, of course. And this is a small example of that. Just as a pointer, you don't really have to know all these things. I'm just making sure that you are informed about them. These logs are normally overwriting themselves after they reach a certain size, or they can be configured also to overwrite after a certain period of time, right? So in any case, they will not grow indefinitely. You don't have the space for that. Depending how you envision your security, they may grow more or less, and they might be sent to a more permanent storage sooner or later, right? So what often happens is that the files, before they are overwritten, are packed, so you normally just tar-gz those files and save them for a while. In most companies, they will try to secure minimum 3 months of logs, which is not enough, because we already said that any advanced attack, it takes average 6 months, which means that in 3 months, we are not even near to what we need. But if they don't have the resources, they don't have the money, they stay with 3 months because that is like a minimal amount of time in order to stay compliant. But as I said, normally they are sent somewhere for an external storage and then they are no longer in CM, they are packed and saved for a while, so you can still access them after a while. Since these are text files, they compress well, and these Linux logs are normally kept longer because the fact that you can easily compress them, so plain text, mostly, it allows for bigger storages, right? So again, file rotation policy will be in the log rotate conf file. So if you want to understand what and how it's being saved, are they rotated daily, weekly, monthly, yearly, whatever, you have to check the log rotate conf file. But it's not what you need to really know. Here I'm just guiding you through it. How to collect the logs, I'm pretty sure you will find your own way. So this will be a very short guide through this. And now let's finish with this part. But I can also tell you about some important investigation aspects in Linux. Now, what is different between Windows and Linux? First of all, a registry in Windows contains a huge amount of important data for investigations, right? It is a sort of a centralized place where Windows stores different data, different settings, and so on, right? In registry, you will go there to see which files were executed, for example, right? Because it contains even that information there. It contains the user data, it contains the account data, all sorts of things, right? It contains caches, secrets, a bunch of things will be in the registry. Those things don't exist in Linux. It's basically a bunch of other scattered resources. Something is here, something is there. You have to go in a bunch of places, and some things don't exist at all that exist in Windows. Another important difference is the file system. First of all, how many file systems in Windows you can name?
NTFS, FAT32.
And you will have NTFS, you will have FAT or derivatives of FAT 16, 32, now this extended FAT, right? And that's about it, right? That's about it. NTFS is in place for now more than 30 years, from Windows NT. And it's not even Windows, Microsoft didn't even wait it, they bought it from another company. NTFS was the new technology file system. How many file systems you can remember for Linux?
A lot. ZFS,
I don't know, I mean,
BTRFS.
if we would say there is 20, that would be what, too little, 30, 40, who knows?
X3, X4.
It would be more appropriate to ask which kind of
CryptFS.
file system you will see for which purpose. Because they have file systems created for specific purposes. You will see that there are file systems, for example, made for servers used for streaming. Then we have file systems for embedded devices. We have companies such as Samsung creating dedicated file systems for their own phones. They don't do that. In the past they did it a lot, but then they realized that their phones are really functioning badly because the database got stuck, so then I won't go into that. So many different file systems with extremely different behaviors, extremely different types of artifacts that you can extract from those file systems, and a lot of them have anti-forensic features. Such as, for example, in the ext4, where the metadata about the files are zeroed out. And metadata about the files are what we're actually searching for in the NTFS. Also, one of the main features of Linux is that most data in that operating systems is just plain text, right? So just plain ASCII, and we do a regular grep search. Now, what are some key artifacts in Linux? And here you will also see a comparison between Windows and Linux. etc is the primary configuration folder for system. It is what we would normally go and search for in System32, right? This is what we have. And every application will have its own separate configuration files or even directories, right? So if I'm searching for something specific in an intrusion, I will search for the configuration files of that specific application. So if Apache was compromised, I want to see what happened with Apache specific. The var log, I already explained, right? So security logs, application logs, and all sorts of other things. Very important central logging place for Linux, and the logs are normally there for about 4 to 5 weeks. Home user is basically your user profile folder in Windows, and it will have the user data and user configuration information. So for this specific user, you might want to go and check that, depending what kind of use case we have. The Linux distribution name and version number, it is also in etc OS release file. The installation date, you can also go and check the SSH host key files. I have the example a little bit later, and I will show this, because SSH host key files are important if there was remote access, and often the attackers are opening for themselves an SSH tunnel. That's not an unusual thing at all. And the good thing about SSH keys, it will also give you the destination from which the attacker connected, right? So we want to check the SSH keys for sure. Time zone, forensically, you might want to check what is the time zone, just to make sure that you're looking at the files in the proper context, right? You want to see if this 3 p.m. is really 3 p.m. here in Paris, or is 3 p.m. in I don't know, in Tokyo. So maybe checking the timeline is not a bad idea. User accounts. So the sudoers file group, I already mentioned that. I'm pretty sure since you already did some, I know that you probably did some penetration testing things, they showed you how to do password cracking, right? So you need password file, and you need a shadow file, then you want shadow, and you combine it, and then you try to crack the passwords. Attackers are also doing the same thing, right? So if they need an admin password, they will try to crack it by obtaining the content of the password file and the shadow file. Did you crack the passwords? Sudoers file, one of the main things, as I said, that we checked in the investigation is always who is in the sudoers file. Because you can change the approach to how a user is being able to function in that machine simply by putting it into a position that he can execute commands with sudo, right? If you put the user in the sudoers file, he can do everything like a full-fledged root, right? Full admin. So who is in the sudoers file, you want to check, definitely, because those users are interesting. And again, the groups, we you already mentioned, so I won't bother you. Again, logs we talked. I won't go through that again. Just remember again that we send it to dot. It is hidden files and folders. Web browser artifacts. If you really find a Linux server with a web browser installed, then I guess this might be a use case. I will be surprised that you have something like that.
Yes, for the SQL database, when we browse on incognito mode, I noticed that URL are not stored on for Chrome in the SQL database. I would like to know if there is another way to find all the URLs browsed.
They are in RAM.
In what?
They are in memory.
In memory, but if you
If you reboot, they are nowhere.
you
You don't have to dump the RAM actually for that. There is a we have to remember exactly. Now, but with ipconfig, you can also do the same thing. Because ipconfig can give you it will give you the actual URL, but it will give you the domain, right? It doesn't give you the browsing information. But with RAM, it's actually there. It's inside, right? Everything from a browsing session is in RAM. But in any case, either you use this or you want to try the ipconfig command. It is lost once you reboot the machine. But I still have to see an investigation where Linux will be a client, not a server. So first of all, if it was used for any internet access, it will for sure be in RAM. Because servers don't get rebooted. How often do you reboot a server?
every 2 weeks or month
You reboot it when there is some maintenance, normally.
there is a maintenance. Yeah.
When there is a maintenance. I will be surprised to see servers rebooted monthly. That would be a
Quite
surprise. If it's rebooted monthly, then it's not important. Then it's for sure not important. Important things are rebooted only when they really need it. They need to. I remember once I took an image from a server that was not rebooted for 7 years.
Ah ouais, uptime.
7 years without a reboot. So turned on, never reboot. Also, never properly patched. Because for proper patching, sometimes you have to reboot. Right? So for proper patching, you also have to reboot. I can tell you that that server had double digits of highly exploitable vulnerabilities. All of them with CVS score above 9.5. So 7 years also took that as a consequence. But still, these are the locations of the web browsing artifacts if you need it. Command history, it's in the dash history file, but sudo history. So sudo history is not there. It is in the authentication log and sudo log. So the commands executed with sudo privileges are in a different artifact, not in the same history file. That's a very common mistake that people think everything comes from that file. No, it comes from these two files. SSH, that's a standard tool for accessing all Linux operating system devices. It's not that Linux cannot have a remote desktop, because it has, right? But it is uncommon that they actually install a graphical interface into a server. It is not a common thing. There are some important files that you should remember, and I will show the content of those files. They're both in home SSH. So this is a hidden. Known hosts. The known host file will show you all users that connected from this laptop somewhere remote. Authorized keys, public keys used for logins to this device. So in this and this file, doesn't matter which one I will call it the connection look, it matters because it shows the level of intrusion, of course, but they will give me the IP addresses for the attack. So that's why I did it. Same goes for the RSA, but it's really not that often that you will see. And now the important part. Before we leave, I wanna make sure that we cover persistence mechanisms, backdoors, and potentially suspicious files and directories.
Excuse me, sir, can I get your USB key?
Yes, of course. Somebody returned it, so I'm not sure. Now, these are some most common persistence mechanisms, backdoors, and some of the most commonly used files and intrusions that you will see. I'm not saying that this will happen in every case, but this is what happens in most situations. So, one of the most important points, and that's why I also started that with Linux this morning with the boot process, are the service startup scripts, including initialization scripts. These scripts normally run during boot or immediately after boot, and they will make sure that the malware is also running every time that the computer is rebooted. That's why they are the perfect persistence mechanism. Another problem with these scripts, from our perspective as investigator, is that we have no clue what should be there. Because I can say, run a script called updater. You know how many different updating scripts there are running already in the server. How do I know if this one is right or wrong? How do I know if this script is running called backup, crawl, or whatever is right or wrong? As I said, not even the admins of those operating systems know all these things. So it's very difficult to find things, plus it will be a bunch of text. If I start searching through this, it's going to be tens of thousands of lines. Not a human being can go through this. That's why the best approach, when we believe that there is a persistence mechanism involved, and often there is, most often there is, you should do the diff thing. And it's also advisable to monitor for any access or changes to the initialization scripts, at least these ones. Right? These are the most, these scripts here are the most common intrusion mechanisms when it comes to persistence in Linux. Another one are the scheduled tasks or cron jobs, right? So etc cron and var spool cron, these jobs you should always regularly check. When it comes to persistence, this is what scheduled tasks will do in Windows, and this is what services will do. Also, this is the same methodology that they use with the run keys in the registry, right? With the run, you know, the run key. That's exactly that same type of intrusion.
Run key for persistence.
Yes. Now, there are some there are some most commonly used techniques for creating backdoors. They can do all sorts of things, right? With Linux, they can open shells, they can do a bunch of things, but let's concentrate on those that are more stealthier. Yes?
Yeah, on previous slide, you didn't speak about systemd because now inittab is on my distribution is not used anymore.
Yeah, they changed a little bit, yes, but that will happen, right? I always advise you to look at what is the actual version of Linux running there, and there are two different boot types also for booting the
Below and grab.
for booting Linux versions, right? One is the Debian based, and the other one is more what they do in Red Hat, and there are some differences. It's not a major thing, but there is different order of different files, and so on. So just use this as a pointer. Just use this as a pointer, because this will change, right? We never know with every new distribution of Linux what they will change in this process. So this has to be regularly checked by each one of us, because simply, and for some reason, it's especially now happening in the past 2 years. And also don't forget, if we would have just a little bit more time, I would also do that. We have ways of hardening Linux. There are hardened Windows distributions, which you probably heard about, right? What did you heard about? Windows hardened.
I use Linux Mint for.
They're only hardened, but there is also a way how you can create any distribution to be hardened, right? Which comes with some consequences, but it's also forensically an issue. It's also a forensic issue. If you are using hardened Linux, which in enterprise environment it can actually happen. I will try to show it anyway. I will let you try to show it. Maybe tomorrow morning. Now, what do we have here as a common approach? So it doesn't differ a lot from Windows. The things that attackers do. So more or less the same techniques are used, just with different artifacts. In Windows, they also try to create additional users so that they can come back, right? They do the same here. So creating new users, that's a common attack technique. Those techniques do not change just because it's another operating system. That's why we check for password and shadow file, and we especially look at the UH0 accounts, right? And we especially look for application accounts with passwords. What is an application account? For example, MySQL Apache account, for example, something like that, right? Why these accounts shouldn't have passwords? Because it's not expected that they will have interactive logins. Those are machine accounts. If there is a password assigned for these accounts, it's malicious. So it's a good way when you look at this to identify any potential compromise. Same thing with the authorized key entries with SSH, right? Normally, it is a very limited group of people who has the privilege to use SSH because of its power, right? Because SSH is enabling you to work in the same way, in the same context, with the same power, like you're physically sitting behind the machine. So, always check which authorization are there for which users, was there any connections, and so on. And again, different backdoors created through these different initialization scripts and configurations, especially through configurations like inetdconfig, xinetdconfig, where I can say, okay, open this port, keep it every day from 3 to 5 and so on. This is one of the well-known row set UID files. What does that mean, right? UID is a very specific Linux thing, right? You don't it's not similar to something I can compare directly with Windows. I don't remember that we directly compare it. But you can bypass permissions on a file by setting UIDs, or basically user IDs, right? So if I say that all files in etc config Apache, for example, are accessible only for an admin, some admin there, doesn't matter what's his name, I can bypass that by saying, okay, this is generally the true, but I can say this apache.conf file is accessible for this user because I have changed the UID for it, right? So I don't see that. I don't see that this user has additional privileges. He's still in the same group. He's still just a normal user. He doesn't have anything in the sudoers file, but he can access a critical file. This is much more stealthy because, first of all, you would need to know all the files that are critical, which is impossible. You never know which files are potentially critical. Second of all, there is a lot of them. So what they're doing is, instead of clearly doing something that is visible, right? Create a user, put him into a root group which has all those privileges, they will just change the UIDs on the files. Directories starting with a dot and file name starting with a dot, those are hidden files. I'm sure that's something you will be able to identify. This is another also commonly used thing. Regular files in the dev directory. As I said, in Linux everything is a file, so also all your hardware components are a file. But in dev directory, there are no normal files. There are only devices. Anything that is in the dev folder that is a normal file is malware. There is no situation, this one that I have ever heard of, that there can be a legitimate, regular file in the dev directory. So, if you discover any regular files in the dev directory, make sure to check it because it is for sure malicious. It is not possible to have anything else except devices in there. Recently modified files are an indicator, of course, because what we will do if we have an intrusion, let's see what are the most recent files in that thing. This is a problem if we rely on this because of a very specific thing for Linux, which is called the touch. Do you know the touch command?
Yes.
To create with timestamp.
And that's a problem. Touch command will change the timestamp on anything that it touches. So if I'm an attacker, I can just do touch from root below, and I change the timestamp on anything. It doesn't change timestamp in every part of the file system. So same as in Windows. Did you did that TFS already with UTT? Did you did the file system NTFS? Did you have those lectures?
You have access time, creation time.
Yes, but do you know when are those times stored?
On the metadata of
Yes, but there are two artifacts that store date and time in Windows. File is the file attribute, the other one is the system information attribute. Two attributes. One you can timestamp, the other one you cannot or at least not all the fields. So when we are doing the investigation in Windows, we don't look at the time that Windows is showing. Because Windows, the time that you see on the screen, that one is not reliable. But Windows has a backup artifact that also contains the timestamp. It's also true for Linux, but not for all operating systems, or better yet, not for all file systems. Depending which file system it is, you might have an additional artifact that you can compare the time, you might not. Some file systems don't even have the value of modified time. They don't even keep that time at all. So this is a very file system depending artifact which you may or you may not have. That's why it's important to understand these file system issues. Any large files are indicators. Normally, creation of large files is monitored. And in general, the disk quota is monitored. You will see tomorrow when we talk about this basic security of cloud, that we also monitor for disk occupancy. It's not just, okay, disk is 100%, it will stop working, it's a problem. But also sudden occupancy of the disk is an indication of the attack. If somebody has infected my SQL server, what is probably going to be the first next thing that he's going to do? So you have planned to compromise my SQL, you did it, what is the next step that you will do? So you are now on the SQL server, what is the next thing that the attacker does?
Persistence.
That's the database, exactly. The very next thing that they do is dumping the database. How do you know that the database is dumped? Because it will create a large file. In general, that's why I said, monitor for sudden disk space, occupied space being suddenly increased. And people don't really understand the connection between this and the attack itself. And there is a connection. There is a connection. There is a CM rule for that. There's actually a CM rule for that. Some years ago,
You can use metadata for find, for example, organized modified file or other.
that depends what you want to find.
If I want, for example, to find modified file, I can
Yes,
use
If
metadata
you have that golden image, a baseline, yes.
with the similar snapshot.
Yes, it is used. It is also used.
It's possible.
That's also a common use forensic technique, and it's a very good approach.
If the time
Yeah.
I take a snapshot, another time I take another snapshot.
That's a really good point. That's something that you can and you should use, and in fact we use it in a way that we exclude non-good files. Because with that, when you have the caches of good files, you can immediately exclude all those files that match. Then it leaves you just with the thing that you don't know what it is.
Okay.
So that's another approach that you can do. This file monitoring is another very important action that you should do. That's why they say there are rules. And it's just as an example how that can look. Some years ago, the Croatian weather service national weather service was hacked, right? And what actually happened? They have a website, like say like French weather service, national weather service. Probably every country has one. There's bunch of data, including the weather forecast and so on. But realistically, how many of you have ever went to the French National Weather Service website to read the weather? Probably not a lot. are not allowed to use. I know that I have never went on a German one or a Serbian one. Right, so never. Right, I check Yahoo Weather, I check this, that, some of those apps, right? I never check. I managed typing French National Weather Service, right, and then going on the website. That's probably not going to happen. So they never had a lot of kids, right? And one day the admin comes and says, this week we had 2,000 kids, right? Normally they have like 200. Like, we have 2,000 kids, that's really good. People are liking us, right? A week later, it's 20,000, right? Another week, it's hundreds, thousands of visits. Wow, people like us. You're doing a great job. Everybody's proud. They call the director, right? But a month later, the FBI calls. And they called them because they were hosting child pornography. Not only that they were hosting a lot. And that link was shared to the entire pedophile community. So the pedophiles from the entire world were downloading child pornography directly from that website, from the Croatian Weather Service. If that admin do his job, he will first of all immediately saw that his disk space went from 20% to 95%. So there are huge amount of files uploaded there. Second of all, I would ask myself why somebody from Malaysia would look at the weather in Croatia, especially on that website, in Croatia. They didn't do that. What they did, they had the vulnerability for some Linux, right? They create a folder because you know how Apache, just folders, right? Every slash that URL is just a folder. They create a folder somewhere deep, but it's not easily usable. They copy the data there, it gets SSH, done. It was that easy, right? All they have to do is then send a link to everybody else. You will immediately saw that, even without a single visit. You will see that the very same day where the guy did it, just by monitoring sudden disk changes. That's all he had to do. He didn't. So he had one indicator even before the content was shared, the other one was clear. Just by the fact that you have thousands of users coming from all around the world, and you have 200 per week only from your own country. So something is wrong. And I know you're close to the end. I will try to be quick now. Now, DD command. DD command is a built-in tool. Hopefully, this still is. I don't know what's the next thing that they will decide. Maybe taking out the DD. But it's directly created to back up and restore entire card disks or partitions. It can also restore any specific part of the disk that you tell it to. I can restore specific sectors if I want to. Often it is used to copy specific regions such as the master boot record. So in case of some compromise, especially viruses, they are known to destroy the master boot record. You probably heard about that, right? Once the master boot record is destroyed, then the system is down and you're dead. What we often do, there is a script running every week or so, right? When it does the backup, it also backs up the master boot record, right? Just those few hundreds of bytes, right? So there's also an application for that. It can also convert data formats and so on. That might be important if you have some of those exotic file systems. With now with ext4, not that relevant, but I will just show these important commands. that I would like you to remember. So first of all, this is full physical disk imaging. So this is a bit by bit copy of your hard drive. That's a very important thing to remember. What is DS?
The offset. The offset.
Not the offset. It is the block size. What is this and why is it important? Because this is very important. What is this?
Because these are structured in blocks. And the
Don't copy
maximum
part is a block.
capacity of blocks is 4096.
That is yes, and I mean yes. Let's say yes, but let's explain it. Let's explain it in a different way.
Because the translation.
We have sectors and clusters, right? We have sectors and clusters.
Yeah,
What is a sector?
it's a part of disks. In disk you have a lot of sectors.
This can be formatted in multiple ways. When you have a disk, this is like a white paper, and you know how you have those that's a good example, right? Look at it, right? These are the lines, right?
Yeah.
There are the lines in squares, right? So if this is white, I can make it in lines, I can make it in squares, I can make it in triangles if I want to, right? But this line is what? The smallest allocatable part in which you can write your words, right? This is the same with this, right? Block size is the smallest allocatable unit, Let's show it directly. Let's do it like this. Actually, no, I'm going to show it like this. What does it say here?
Basically unit size.
So
We have choice.
you have the same choice in Linux. You have exactly the same choice in Linux. It says allocation unit size.
Okay.
What does this actually mean? It means
The smallest space.
not just that. It means that the minimum that one file can occupy is 4 kilobytes. Which also means no, something else happened here. Look at it here. Size 49 bytes. Size on disk.
0.
And how is it possible?
Because we achieve the limit.
It does a rounding.
For the other. If we
As I said, 4K is the minimum size a file can take. So why is this one 0?
achieve the minimum size.
Minimum size of 1.
5. Here we
Of data.
What is the minimum size of 1? No, it's not. It is not. It is actually not. It is not like the file needs to be minimum 4096 bytes. It is the smallest size that the file can be, but not in that way that you're looking at. Why is this file? It tells you size on disk 0 bytes, but still it has size of 49 bytes. But the size on the disk is 0 bytes. So where is this file?
No, the file is on the disk, but
It's actually on the disk.
the amount of data is not enough to complete an allocation unit size.
It is not. It is not.
there is still an empty space allocated in this.
It's still not circle.
Each byte equal 44.
Each letter here is exactly as it is represented, so it's 49 bytes, that's true. Why is this the case? Because there is something that is called resident and non-resident files. Do you know where is this file stored now? It is saved in the MFT. This file is now stored directly in the master file table instead of on the disk. And why? Because when the file system was created, its primary location for storing files was not the disk, it was the MFT. And if the file is small enough to fit that resident space, it never goes on the disk. That's why this might not be the best. This also has serious forensic implications. And why? Let me also show you this. This is something that you should know.
So for all the files that don't achieve the minimum size of the unit size,
It's not the unit size. It is the minimum size
minimum size
for the resident file.
for the resident file in this example is 400 and
No, it doesn't have anything to do with that. The resident file size is a file attribute in the MFT. That's why it's very complicated. It would be easier to explain this if you already did some file systems before, but they didn't explain. It's very difficult for me now to. This is a full day explanation. So it is not concerning anything that is file allocation in that way. Let me show you this. Look at this. I think this should be enough. I'll add a few more, just for the sake of being safe. This should be enough. So what happened now?
The size on this has increased.
As I said, minimum size that the file can occupy on the disk is 4K. The size of this file is 878 bytes, but it still occupies an entire 4K sector. Also, don't forget that this file originally was not on the disk. It was in the MFT. It was on the MFT. What happened with the original file from the MFT?
Can you repeat?
So what happened with that first file, the original file from the MFT?
Delete the MFT?
Overwritten?
That file is still there.
It is in memory.
It is still in the MFT. And it will remain in the MFT even if I delete this one.
And by default, when you create a file, is directly what is considered as the
I don't keep it, sorry.
by default,
Yes.
when you create a file,
Yes.
is directly stored in the MFT as third position?
If it's initially small enough, yes. If it is immediately small enough, yes. If it's not small enough, then no.
Then when you really careful.
So, why is this important? Because this file that was originally small stays in the MFT even if this file gets deleted. So if this file is no longer on the disk, that first file that you saw is still in the MFT. And during how they balance this tree in the MFT, it can stay there for a very long time, but I won't bother you with that. So, this is an important thing that you should also remember also from the perspective of Linux. Now, let's move here. Why is this block size important? Because it has to read the content in the way how disk is divided. Because if my operating system is reading the data 4Ks per block, you need to read it also, right? Imagine if I say read the data 4Ks at once, and here the default one is 512, right? So it's not the same structure anymore. It will create problems. So you have to know the block size before you start imaging. You should know that. The default one is 4Ks, but as you can see, you can change that.
By default, by default is 4K?
By default is 4K, yes. By default is 4K.
In this case, where you wanted to format in the two, at the lesser size, 512 kilobytes. What will happen if you read 4096? Is it going to take the sequence of 512 as large again?
It's very difficult to understand what will happen because it will depend from the file system that you are imaging and also from the tools that will have to interpret that image. That's why I can't give you that exact answer, but it's not something you want to do.
Okay, sir.
So, one last thing that I want to make sure that you're aware. Please make sure that you understand the meaning of if and of. Yes? Because I have seen very experienced people who have mixed up if and of. And if you mix up if and of, what will happen here?
We're not copying the right one.
That would be, then they would say never mind for that. There will be something much worse happening. If you mix up if and of, you will immediately destroy the disk that you're imaging. Immediately. The moment you press enter, the data is lost. Immediately. Right? So, please make sure that if and of are not checked twice, but 3 times, 4 times checked. Also remember that you can take specific parts of the disk. You can do a lot of other things. You can back up the master boot record, as I already mentioned, right? All sorts of things. It's also used for troubleshooting this option. The rest we can leave. It's fine. I know you probably want to leave. I see already people are back. So we will stop at this point, and we will continue tomorrow. So tomorrow we will be mostly concentrated on the cloud, and I will try to cover some of the most important things. There is also a lot of theory that we need to know there, and I would also like to start with some of the practicals. Tomorrow show some security, basic security that you should know about cloud. Okay? Okay. Cool. Then I see you all tomorrow.
Thank you very much.
And if